So very good morning to you all, and today we are going to start second part of our topic field theory. Although in first previous part we discussed few theoretical framework of field theory, and now we are going to discuss few numerical related examples or some you can say problems related to field theory, and to handle those problems with the existing models. I am Dr. Ritesh Singhal, your instructor, and this topic is specifically for MBA program for second semester, and the subject name is Quantitative Techniques for Management. So students, let's start and learn what is being discussed in field theory part 2. In previous video, we discussed there are two types of models. One model is deterministic and another model is probabilistic model. So deterministic model is basically the model where we have fixed kind of you can say model where the people coming and going of people from the system is generally fixed. So that is called deterministic model. But in case of probabilistic model is basically the model where there is probability associated for service, for arrival, or for any kind of characteristics of field model. So probability is always there, where we need to answer the question with some probability, because there is no deterministic value exist. Okay, so let's start with one of the probabilistic model, and the model name is, this is a general notation, and the model name which we are going to start today, that is MM1 model. MM1 model. MM1 model means first M denotes the Poisson arrival, Poisson distribution arrival. Second model is Poisson departure, and this one is basically relates to single server model. Single server model. So let's have the characteristics of this model. Like, these are a few characteristics. Students, you should remember these characteristics and remember the formulas also, so that you can handle the problem related to field models. First of all, lambda is called arrival rate. Generally, the unit of arrival rate is like per hour, per minute, or maybe per second. And it is also recommended that you should use the same unit for service rate also. In one question, you should have same unit. Either both the values of lambda and mu should be taken either per hour or per minute or per second. Next is queuing length. Queue length means the length or the average number of customers in the queue waiting to get service. And the second thing is system length, that is average number of customers in the system. So the one difference is here the average number of customers in the queue, and here the average number of customers in the system. So it is always true that the value of LS is always greater than LQ, because system is very large as compared to queue. So we should have the greater number of customers in the system as compared to in the queue. Similarly, we have waiting time in the queue and waiting time in the system. Here also, since it is time means either it is given in terms of hour, in minutes, or in seconds, and here WS is always greater than WQ. You should remember this thing. And one thing also you should keep in mind, that if you take the unit of arrival rate as per hour, unit of service rate as also per hour, in that case the unit of WS and WQ would be hours. Yeah? And similarly, if you take per minutes, then it will be minutes. Then we have rho, that is called busy time of the server, and this is also known as the probability that the server is busy. And when you say it is probability, then the value of rho would be between 0 to 1. Similarly, when you subtract this value with -1, -1 minus row, in that case, this would be the idle time. For example, if the value of row in any case is 0.2, in that case, the value of 1 minus row would be 0.8. Okay, it means 20% time if server is busy and 80% time if server is idle. Idle means it is not doing any kind of work. Now we have formulas of all these characteristics. The formula for row, that is traffic intensity, it is also known as operational efficiency. It is also known as server busy time. All the things are related to this particular server busy time. Similarly, when you subtract this value with 1, then it is called idle time. Idle time of the server. These are 4 different formulas: LSLQ, WS, WQ. Frequently, these characteristics is being asked in different questions. And the beautiful aspect of this thing is that in all these 4 formulas, the only 2 things are required, only 2 parameters are required. One is mu and another one is lambda. Okay, so you should clearly identify mu and lambda before starting the problem, and then you can use any one of the formula. The 5th one is probability of having exactly n customer in the system. For example, if somebody asks you, what is the probability of having 5 customers in the system, 10 customers in the system? So just put the value of n into that, either 5 or 10 or 2 or 4, whatever, then you will get the probability of having n customers in the system. Where row is, this is row. Row is nothing but the server busy time, which is discussed here. The last one is the probability of having number of customers in the system n exceeds a given number r. In that case, probability of n greater than r is rho to the power r plus 1. This formula is also being used in few questions. Otherwise, first 5 or 6 formulas are most important. You should keep remember all these formula while doing the question. So let's do it. And there is one example I have taken from your book, and this example is given in page number 531. You can see this example, and this is a solved example. You can handle this. So question is like this: the number of customers approaching to tailor shop appears to be Poisson distributed with 6 per hour. So this is what? This is arrival rate. This is called arrival rate. Arrival rate means lambda. So here lambda is nothing but 6 per hour, clearly given. The tailor means server. Attend the customer on first come first serve basis at an average rate of 10 per hour. So mu, that is service rate, is 10 per hour. So lambda and mu. This is the first task. In every question you should identify clearly the value of lambda and mu. So lambda and mu is 6 and 10. Students, one thing you also remember while doing the question, that the value of mu is always greater than lambda. Okay, so you should verify this thing before writing the value of lambda and mu. So let's do it one by one, all the parts, and see how the results would be there. First part is the utilization parameter, traffic intensity, that is denoted as rho. Rho is nothing but lambda by mu. Here lambda is 6, mu is 10, so the rho is 0.60. It means it is clearly indicated or understood that 60% time is server is busy. 60% time server is busy. And what is the probability that system is idle? That is 1 minus rho. Means 40% time server is idle. Second part. This value comes in terms of probability or percentage rather. Third part, the average time that tailor is free on a 10-hour working day. So if tailor shop is open for 10 hours in a day, and you know the free timing, the probability of free timing is 40%. So 40% of 10 hours is 4 hours. So it is very easy to write this thing, that in the entire 10-hour working day, this tailor is free on an average 4 hours daily. Okay, so next part is part 4, expected number of customer in the tailor shop. Expected number of customer in the tailor shop. When it is number of customer and when it is shop, then you should write LS. And similarly, if you attempt this fifth part, this is LQ. And students, the formula for LS is, I think I will just show you. The formula for LS is, you can see here, lambda upon mu minus lambda. So you can write it here, lambda upon mu minus lambda. So here in our question, lambda is 6, mu is 10 per hour. So we can write these values here. This is 6, this is 10 minus 6, 4. So you can write it as 1.5 customers. 1.5 customers. Similarly, LQ is, the formula for LQ is lambda square upon mu into mu minus lambda. So here you can write lambda square upon mu into mu minus lambda. So when you calculate this value comes out to be around 0.9 customer. One thing you should also keep in mind while solving this particular question, that value of LS is represented as number of customer, and it comes out to be in terms of fraction or in terms of fractional value rather, or in decimal. So you should write the answer whatever you are getting. Don't try to truncate it or round off it. You just write whatever the answer you are getting. It is up to decision maker who can understood this value as 1 or 2, whatever. Now, sixth part, time spent in the queue. So that is WQ. WQ is here. Formula for WQ is, yes, lambda upon mu into mu minus lambda. So when you put this value here, the value of lambda and mu, you can see this comes out to be 1 by 4R. 1 by 4R. And in terms of minutes, it would be 15 minutes. Okay. And WS is 1 upon mu minus lambda, and it is 1 upon okay students, yes, we got the right answer. That's 6 upon 40. 6 upon 40 hours, and this comes out to be 6 upon 40 hours means, if you convert this value in minutes, so you can write like 9 minutes. And similarly, 1 upon mu minus lambda, that is 1 upon 4 hour, and it is 15 minutes. So by this way, you can write the answers. You can convert these value hours into minutes, and so on and so forth. Let's have few more cases here. The last one is point number 8, the probability of having 0 to 5 customer in the system. In the previous list of formulas, you can see that Pn is nothing but rho to the power n into 1 minus rho. This is the probability of having n customer in the system. So here, rho is 0.6 here. You can see here, rho is 0.6. Yes, exactly, rho is 0.6. This is the same example. These are 8 parts, 1, 2, 3 in this slide, 4, 5, 6, 7 in this slide, and 8 in this slide. So here, write down a table, n and then Pn. Okay, so write it at 0, 1, 2, 3, 4, and 5. So put it the value of n is 0 in this formula, and you will get 0.4. This is 0.4. When you write P0 and rho to the power 0 into 1 minus rho. So rho to the power 0 is 1 and 1 minus rho is 0.4. So you can write it as 0.4. Similarly, when n is 1, this value is 0.24. When n is 2, this value would be, students, you are advised to solve this portion by you only, so that you can match the answers. And when n is 4, it is like 0.05184. and the last one is 0.031104. Okay, so put the value of n is equals to 1, n equal to 2, 3, 4, 5, and so on. So this is the way how you can handle the question. If you have one more example here, you can see this example as a self-service store has one cashier, 9 customers arrive on an average every 5 minutes. So when 9 customers arrive in 5 minutes, in that case lambda is 9 in 5 minutes. So you can say like this: in every 5 minutes 9 customers are there, so 108 customers per hour. So you should convert this value into some meaningful observation, and in that case the service rate is 10 customers in 5 minutes. In 5 minutes he can handle 10 customers, so in 60 minutes he can handle 120 customers. So 120 per hour. So now this is the important part of the question. Lambda and mu is now identified. Now one by one you can handle these questions. First part, number of customers in the system, that is nothing but LS. Average number of customers in the queue, that is LQ. And third one is average time spent in the system, WS. And average time that a customer wait before serve, that is WQ. Now students, you are advised to solve this question by you only and match the answers, and this is up to you, and because this is an exercise, you can do it, and all the formulas are given here. Use these list of formulas here in this slide number 5, and solve this particular example here. So it is up to you, and solve this example. Okay students, if you got any problem, you can write down in the description of this video. Then we have few more cases, like this is one of the case when customer arrive at a rate of 12 per hour. So this is just lambda 12 per hour. Model is MM1. Obviously we are having one single model in this syllabus, so we don't need to worry about another models, although there are a number of models available. And the service rate is 1 in every 3 minutes. 1 in every 3 minutes means the server can serve one customer in 3 minutes. So how many customers he can serve in 60 minutes? Okay, so how you can write it? How many customers he can serve in 60 minutes, in 1 hour? So it would be 20 per hour. Okay, now this is part is done. Now one by one you can find the value of rho here. This is lambda by mu. Then we have average number of customers in the system, LS, waiting time in the line, WQ, and waiting time in the system, that is WS. So this can be solved easily, and you can write the answers. Lambda and mu are given here in a very well defined format, and you should write the answer. So students, this is one important task, that in each question you should clearly identify the value of lambda and mu. Otherwise this question would not be going further. Okay, so there are a few more examples. You can do this example from your notebook, that is on page number 533, and solve this example. And this is up to you. Here again the things are very clear. This is lambda 8 per hour, this is mu 6 per hour, and you can solve these values. So this is again a solved example in your book, page number 533, and you can solve it. So students, that is all from my side today, and hope you understand this session. We have done a number of operating characteristics of the queue model, and we should remember all these formulas. Do whatever we are doing, what we are doing in this video, how we can handle the question, what first we can find out, and how we use the formulas and write down the results. So students, thank you, and we'll meet in next video, and Hope you are doing better, and goodbye. Take care. And that is all from my side. See you